Okay. Hello. All right, still recording. So this is kind of one of the strangest ways I've ever taught. So just bear with me. Um this is your teacher. I hope you're hearing this. Um Hello. I hope I've had my baby and Silas is healthy. Thank you in advance for bearing with me and having to hear me attempt to teach through this like crazy video thing instead of being there in person. Um, it's just kind of laughable, my situation right now with my huge belly sitting on my bed literally after midnight, December 27th. Got my little headset on, trying to get some better audio for you guys. Actually using the Xbox Gamer something or other on my laptop. So I'm recording this as if I'm like some like, I don't know, hardcore Xbox gamer. That's kind of hilarious. So I hope this all works. Um, yeah, this is even stranger than doing Zoom because at least Zoom, I you know, COVID era shout out. At least on the other end, I had people being like, "Yeah, we hear you, Prof. We understand." So I'm gonna try to teach in a way that hopefully you will understand and maybe over explain some stuff. I don't know. Hopefully, the other kind people who are there overseeing the class can also help you. Um, yeah. Okay. So this video is mostly going to cover 5.6a, and I say 5.6a because we're not covering the second half of 5.6. There's only one little part of 5.6 we're doing. It regards trapezoidal sums. We're not doing the rest of the section. So if you're looking at your textbook, we're not doing Simpson's rule or error analysis. Also, again, I was just going to say as kind of like a little added to my list of preemptive apologies, I don't have time to edit this. I really don't have time to be making these videos, but it is what it is. So, you know, I don't know if if I need a drink of water, or I don't know, if I make a mistake, I have to erase. Sorry, I'm not going to edit it out. It is what it is. Maybe I might I don't know, I might make a silly mistake and do a whole problem wrong, and maybe you guys will call me out on it. I don't know. Uh, well, I don't think I'll do the calculus wrong, but you know how it is. Anyways, or if I don't know, you hear like a weird sound, or right now my kids are sleeping, but later on I'm sure I'm going to be making videos when they're awake and someone's going to knock on my door and I'm going to have to tell people to go away or something. I don't know. Anyways, apologies in advance. These are not like professional level videos. This is me trying my best. All right. So 5.6. All right. So it's called numerical integration, whatever. I'm just going to call it trapezoidal sums rule, whatever. It doesn't really matter, sum or rule. So again, A, so we're not doing Simpson's rule or error analysis. Just this trapezoidal thing. So hopefully at this point, hopefully I made it to my C-section plan date, and hopefully I was in person to teach you everything up to the very last part of 5.3, which was pretty easy. I gave the whatever sub instructions on how you can just kind of read the end of 5.3. So hopefully I've already in person taught you how to do rectangular sums, essentially, which we call Riemann sums. And now we're going to do trapezoidal sums. So as you probably, you know, if there's like a curve, right before we did like, oh look, there's little, well, that's not perfect, but it is what it is. Right, if we did like a left hand sum of rectangles or whatever, right? Yeah, it's a little bit too high. Right, it's like, oh, that's an underestimate. And if we did like the right-handed sums, then they would have kind of looked like this. And hopefully we also already talked about how, right, like for a function increasing, a left-hand Riemann sum would be an underestimate. For a function that is increasing, a right-hand Riemann estimate, as we see here, is an overestimate of the real curve. Anyways, but now we're going to talk about, well, what if we could kind of like split the difference? You're probably already thinking in your mind, okay, well, rectangles are kind of not the best way to do this. What if we just like drew a straight line in between the endpoints at the top instead of made it like rectangles? So, all right, let's see if I can do all this fancy erasing and stuff. Whee, look at that. Such a pro already. If you're curious, this is done using Microsoft Whiteboard. Probably no one cares. I had to do a lot of research to figure out how to make all this stuff work. But anyways, so yeah. Now let's say we had endpoints, I don't know, like here, 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 here. Let's go ahead and like pretend like this goes down further. Do another one like down here. Just do a tiny little eraser thingy. You have to do the thing where it like erases part of the way. Just a part of the stroke like that kind of thingy. Now I feel like, what is it? Not Bob Ross. You know what I'm talking about. The Ross guy who does the paintings, who's like, happy little trees. All right, my jokes or attempt at jokes are probably going to be even worse on the video than they are in real life. So I guess I'm sorry. Maybe they're so bad that they'll be amusing. All right, so let's say we had these little subintervals, right? And instead of drawing like a rectangle, we had to choose which endpoint that we wanted to use as our height of our rectangle. We could just draw a straight line in between them. So then when we went down, the shape that we actually made, it's probably hard to kind of tell from that, but let's see. So if we continued, right, kind of going up from this right there, up from this right there, up from this right there, and then we just connected these with straight lines instead of having to choose one and make them horizontal lines. So if we connected the tops, like the function values at these, whatever, predetermined x values, with a straight line, right? Actually, I'm going to choose, let's see, maybe I'll choose this one just to draw out to make it more obvious. So the shape you would get, right? So the bottom's kind of like rectangular looking, but then looks like that, right? So if I ask you, well, ask you what shape it is, then hopefully you would be like, oh, hey, look, prof, I can read. It must be a trapezoid. I'm so smart. Yes, you would be right. It's a trapezoid if you just kind of like tilt your head sideways. Just trust me, it's a trapezoid. Normal trapezoids, you're probably used to them looking like this. But it's a trapezoid even if we were to not have this thing look like a little triangle on both ends and essentially like cut off that triangle and just had like a, almost looked like a rectangle just plus a little triangle on the end, and then we just flipped it over. So yeah, that's essentially where we get the fact that, hey, it's a trapezoid. All right. And then again, I kind of feel like I'm talking to a wall because I literally am. But the area of a trapezoid, right, normally, well, I guess let's just draw a normal trapezoid just so you can remind yourself that hopefully you're smart, you learned something in geometry, right? Like a normal trapezoid. Let's see what we would, trying to be consistent. It doesn't really matter. I think probably back in geometry, you probably called this like base 1, like base 2, and then you had like a little dotted line here. Whatever, you get the idea. That little dotted line is called the height. All right, so probably back in geometry, you probably said, oh yeah, the area of a trapezoid is equal to, right? Essentially, you could think about it this way, that the area of, if this is perfectly symmetric, it's not going to be over here. Obviously, only one side has a triangle, but the idea is still the same. probably back in geometry you thought of the idea of like, oh yeah, if you take that little area, you can kind of like place it over here and like, right, put that there, and then it's like a new rectangle, right? Where the let's see, what am I thinking of? Oh no, I guess that's yeah. No, that's right. Because that would be essentially a rectangle, but its length is only from here to here, which you notice that's less than the whole the length of B2, but is long, because it doesn't count this part of B2, but it's less, it's shorter than B2, but it's longer than B1. Anyways, if you were to do the math, it's the average. It's kind of like a rectangle with the average of B1 and B2 times the height is kind of like the area of that little rectangle-y thing. So that's how you would think about it. So you would literally find the average of B1 plus, so the average of B1 and B2, so B1 plus B2 over 2 all times H. All right, so this is like the area, this is like the average of what we would call the bases. I'm doing air quotes, you can't see me. So again, this is like the average of B1 and B2. I really feel like Sal, the guy from Khan Academy. It's kind of funny. The average of B1 and B2 times the height. So it's kind of like you're like forcing it to be like a new little rectangle-y thing. All right. So that's important because that's what we're about to do to know how to sum up these little trapezoids. Now we're just going to have more than one trapezoid. Okay. So let's see. Let me. All right. Let's. No. Hello. Erase some stuff. Okay, so now let's translate that into how do we apply that to this guy over here. So this thing over here. Oh, look, there's a little laser pointer. This is kind of cool. This thing over here, and then look, it like goes away after a couple seconds. Boom. Okay, so cool. I know. So for this trapezoid, what we normally call B1. Let's see if we for now, I mean, you're going to use numbers later on, so it's not going to seem so like strange. But like if we call this, well, let's see, this is going to be like A, right? This is going to be like, hold on. So this is like from x equals A to B, right? So pretend like we're trying to find the sum of, right? That's still part of that. This is like an f of x thing, obviously. Going to find the area under f of x from A to B, and we're going to call that our x sub 0, and then we'll call like this x sub 1, x sub 2, x sub 3. They'll have numbers associated with them, and then B will be what are our, in this case, x sub 4. Obviously, this is only using 1, 2, 3, 4 trapezoids. You could use like infinite trapezoids or 1 trapezoid or 50. I don't know. All right, you get the idea. So for this guy, let's see. Let me see if I can be like super fancy. Like take him and move him. Oh, look at that. I am so fancy. Okay. So this guy, let's see, let's do the easiest thing first. This left side length here, so you can see that this left side height would be the y value at, in this case, well, I guess I'm just doing this one from the x1 to x. I hope you guys can see that little thing when I like hover my little thingy. We'll see. So this height here is essentially f of x sub 1, right? That's that height, and then the height right next to it, so that's f of x sub 2, that's that height. Okay, and this is equivalent to base 1. This guy is equivalent to base 2. Right, this whole thing is. And the height in this case is like the width of this little guy between the x's. So in this case, it would be x2 minus x1. But yeah, so this would be, let's see, this one's going to be kind of tricky. Let me get like a, I don't know, a red pen, green pen, I don't know. Let's do something green out here. So that's going to be x2 minus x1. Whatever that is. For now, that's fine. And the problem is going to be, and this is, there's only, the textbook aligns pretty well with the AP curriculum usually, but this is one way where they're not like perfectly aligned because the textbook likes to only do problems where these things, let me get my laser pointer, where there's like spacing, the spacing here is equal spacing, like each of these widths are equal. The AP loves to do the opposite, loves to, make one really like long, say like long width, and then like a short width, and then like a medium width, and then like a really long width. I don't know. Like, so they're all different so that these values, right, are all different because right now, x2 minus x1 would be the same as x1 minus x0, and would be the same, that would be the same as x3 minus x2, and would be the same as x4 minus x3. So we'll come back to that idea. Anyway, so for now, that's fine. We'll just keep them like that. Well, let's see if there's, well, let's, okay. All right, I'll go ahead and let's see if I can do this. Ooh, look at that. That's fancy. Ooh, okay. Sorry. I'm using myself. All right. So if you do have, if big if you have equal subintervals. So if we're doing this in red for a reason, it's also Christmas colors. Though Christmas has already happened for me as well as you. If you have equal sub intervals, then right, x1 minus x0 equals x2 minus, that's an equal sign, minus x1, which equals x3 minus x2, etc. If that's true, then each of these, all of these is equal to, actually let me delete that and come back here. All of these are equal to, well, let's see, right? We're literally taking the whole width is from x equals a to x equals b. So the whole width of the whole thing, because we're trying to find, right? We're trying to approximate, all right? We're trying to, we're trying to, right, we're trying to approximate the integral from a to b of f of x dx. Okay, so if we're going from x equals a to x equals b, each of these individually, right, each of those little things, pretend like those are aligned. Just didn't draw it right. Okay, that is the same width as that, is the same width as that. Okay, and in this case we have 4 trapezoids, so we have 4 widths. So you would take the entire width and divide it by how many trapezoids you have. So that would equal the whole width divided by how many widths you have. In this case, there's 4 trapezoids, right? So there's entire width. It's kind of messy. Nope, can't write with an eraser. entire width divided by, there's 4 number of trapezoids. Okay. Number of trapezoids. Sorry, there's a little pop-up thing. I think you guys can only see this one app that I'm in, so sometimes something might pop up. Anyways, okay. So to get the width of each of them, if they're equal subintervals, then the length of each subinterval is, which is this x minus 2 over x minus 1, right, would be equal to whatever b minus a over 4, if there's 4 trapezoids, if there was 8, not, what did I write? No, not number of trapezoidal. I'm trying to talk at the same time. Number of trapezoids, right? Yeah, so this is entire width over the number of trapezoids, right? Hopefully that makes sense. I don't know. I'm hoping somehow either myself or maybe the sub or something can make these videos available to you, so that sometimes if I feel like I'm rambling and I'm afraid that, I don't know, maybe you need a second listen to my explanation, that you can do that, because I want to at least get through everything and not just assume that people aren't on board. So I'll assume you understood that. All right, great. Moving on. So if that's the area of a trapezoid, when we had the B1, B2, H thing, that means the area of each of these little trapezoids, right? So now when we have these, let's see. So now we have this area of a trapezoid for these numbers is going to equal, all right, B1 plus B2 is now, in this case, f of x sub 1 plus f of, oh no, let me erase some of this stuff. Hopefully I can just erase this, and you've already copied it down. I guess you can go back and like screenshot earlier things. I don't know, do technology stuff. Okay, f of x sub 1 plus f of x sub 2, right? Because that's summing up the bases, dividing them by 2. You're just taking the average of those two quote-unquote bases, which are technically heights because we just rotated our trapezoid, times what used to be the height, which is now technically the width, which is now this x1 minus x2. So times the width, and the width is, in this case, b, so this, I'll write according to the book's formula for now, with a big ol' like warning. So this b minus a over n. This n is the number of trapezoids you're using, and b minus a is the, let me go ahead and write this back again, total width. So this is the total width, right? And this is the average, right? This part still is this whole part here is the average height of the two sides, right? So the average, ooh, that's weird looking, average height of the two sides. You know what I mean. Hopefully you know what I mean. You guys can help each other. You know what? If half the class thinks I'm talking like a crazy person, maybe someone can step in, you know, set them straight. Okay. Now that's just, again, let me go back and make this very clear. In fact, let me see if there's a highlighter that's not yellow and happy. Let me see if there's an angry highlighter. Oh yeah, here's an angry highlighter. Let's see how crazy this red highlighter is. It's probably too, whoa, there we go. Yeah, it's a little bit angry. So this is super, right? This and this. All right. This is like big old warning. if, this is a big if there's equal subintervals. Okay, so again, I'm going to write, so the textbook, well, let's see, let me write this. The AP type questions, and I'm going to go over the worksheet problems with you in a second. The AP questions are usually not, can I move this all over? Oh, look at that.